Hey everyone, this is my Physics 2212 Lab 3, and it was on circuits. The purpose of this lab is to predict circuit behavior with series, parallel, resistors, measure current and potential with multimeters, and explore resistor and capacitor behavior. The fundamental principles that we had to use. We had to know the junction rule. The current flowing into a junction must be equal to the current flowing out of it, and then it's a result of charge conservation. The loop rule, which is the sum of all the electric potential differences around a loop is zero, and it's a result of energy conservation. And then Ohm's law. Current through a conductor between 2 points is directly proportional to the voltage across the points. Charge conservation and energy conservation in series circuits. First, we had to assemble our circuit. So we had to follow these steps below. And in the end, me and my group, we came up with this circuit here. Now, the results. The ammeters had a reading of I1, so for the current, which was equal to 19.2 uh, milliamps, which converted to amps is 0.0192, and then I2, which was equal to also equal to 19.2 milliamps, which is 0.0192 amps total. When we reversed the readings for one of the ammeters, we got a negative version. So we got negative 19.3, so a slight difference. And then when we included a voltmeter, we got a reading of 1.552 volts while the voltmeter was attached. However, when it was attached and detached in both scenarios, the ammeter's values did not change. So the amps did not change. This is likely because the voltage is zero, the change in voltage. And the voltmeter has very high resistance, so little current flows through it. Ammeters have a very low resistance, so the current will flow through it instead of the 100 ohms resistor, leading to a higher amps value. And we came up with that after putting an ammeter back within the circuit alongside the 100 ohms resistor. And then you can also see some of the results of our findings within the graph right here as well. And then for RC circuits, after creating our circuit, we observed that the bulbs got brighter and turned off over time since the difference in voltages between the battery and the capacitor approached zero. Potential errors. Human error, more than likely, because we had to stop the stopwatch and the capacitor at the same time, and then also perhaps some of the calculations while we were doing the math. Our what if. What if you charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Will this prediction happen in real life? Explain. Our model would predict that the capacitor would charge instantly. However, this would not happen in real life since the capacitor would have internal resistance at play. This is likely due to the electrons moving within the capacitor as current flows in the opposite direction. And thank you for watching.